In this lesson, we're going to look at the Dalton model for the atom. Now, as you've probably guessed, this isn't in fact Dalton. This is Democritus, who is a Greek philosopher, and he lived around about 400 BC. Now, being a Greek philosopher, that meant he would hang about a rock called the Areopagus in Athens, thinking about things, and he did a lot of thinking about what everything was made of, and he came to the conclusion that everything around him was made of very, very small, invisible, undividable units called atoms. So, according to Democritus, all matter was composed of a single, undividable unit called the atom, which comes from the Greek word atomos, which means undividable. Now, this idea held pretty much up to the end of the 18th century, when somebody called John Dalton extended this model. So we're talking about round about 1800 AD, and so this is over 2,000 years after Democritus. And by then, scientists knew that the matter around them was made up of a number of elements, and at that time there were only about 20 known elements. And Dalton proposed that each element had its own particular distinct atom. So, whereas Democritus assumed that all matter was made from this one undividable atom, Dalton's model proposes that each element has its own distinct atom. So he devised symbols for each of these atoms that were used to construct each of the known elements. And for each of these atoms, he had a go at working out the atomic masses. Now, these estimated atomic masses aren't bad for a first attempt, bearing in mind the inadequate apparatus that he would have been using. But what is important is that he realized that the masses of each of these elements were different. So the atoms have different masses. Each atom has a different mass. And also he realized that the atoms combine in chemical reactions in fixed proportions. And when they did so, they formed molecules and compounds. So the idea of molecules and compounds were also introduced by Dalton.